So the next question that we are going to take is, so imagine we have a block kept here. So let's say we have like 5 blocks, 2 are hanging and 3 is on the table. And let me put the mass of each block maybe 2 kg. So 2 kg, 3 kg, and 4 kg are the masses. And the coefficient of friction for each block is given distinct differently. So the 2 kg is having 1, 3. Uh, no need to write mu s, just write mu. So we want to take the same value for mu q. The mu for this is in 0.2, and the mu for this is okay. So so
And the mass of the two blocks.
yeah, something. So maybe I can give this mass as 20 kg, and this says uh, okay. So I'll keep on changing the values to solve the question. So these are the values given to you. So now you know that how the system will move. So before we decide the motion, we first look for the net pull force without
So
friction.
can we
Okay.
solve?
Yeah, you can solve. But what you will solve? What you are going to solve? Find here.
Sir, acceleration,
No. The question is find the
tension.
tension in each state. Yeah. And also find the friction force acting for each block. The question is not difficult, it's simple. Fine. So find the tension in each state. So the calculation of tension will definitely need the acceleration. That is like indirect question.
So I got acceleration is equal to 1 meter per second. So,
Okay.
so now tension in the first string that 180 newtons.
Okay.
Then tension in the tension in the fourth string, that is that 15 kg string is 165 newtons. Then so that
Okay.
can calculate the
So
two and
this,
two.
this yeah, this tension is definitely 150 Newton. Let's take G as 10. So just to keep it simple for all cases. So now this is 150 because the gravity is. I mean, okay, no, no, this is not the case. You're making
So that's
mistake here.
165 newtons. Uh, that 165.
Okay. So first of all, yeah. So now you need to first how to proceed questions like this is you need to first check the net pull force and net frictional force available. So if you calculate all frictional forces for each block and if you add all the limiting values just for the check purpose because this is 0.3 so it turns out to be 16 Newton, right? So the 4 plus 6 plus 6 is 16 Newton. So 1 6 Newton is a maximum limiting friction that the three block together can develop. So that is the first checkpoint. Now we check for the net pull force. So on the one side it is 20 kg, on the other side it's 15 kg. So it turns out to be the net pull force is 5 kg, which means 15 Newton. So 200 minus 150, so that's 15. Now because the net pull force,
Yes.
supporting force and the opposing force, if we check, we can understand that it will move. And because it will move, so friction will be kinetic and things will be easy for you. So here things are really easy. The finding the acceleration is pretty easy. It's 50 minus 16 upon all masses, which is 35 plus 7, 9. 35 plus 9 is how much? 44.
44.
So now we have 34 by 44, right? This is a value. So the acceleration turns out to be 17 by 22. And now we know the tendency of acceleration, it will go up, the amount will go up, and everything will go left here without any doubt. So if I call this tension as T1, this as T2, this as T3, this as T4. For T1, we can say that T1 minus 150 must be equals to 15 into 17 by 22. Okay. So this turns out to be something very weird, not an integer value, but nevertheless, it's a value. So now similarly, we can do it for T2 and T3. So because if you look at the T2, the T2 is pulling this way, and definitely the friction is opposing this way, and that is equals to just 4 Newton. And because the acceleration is same for all, so we can write T2 minus the maximum friction force 4 because it's rubbing the surface of friction is kinetic, so we can add the value directly equals to mass into acceleration, which is 17 by okay, 34 by 11. Okay, I'm not solving this, and then you can proceed further and you'll get the answer. So this is pretty easy question. The purpose was not this question. The purpose is something you can see on the right side. So now on the right side, if you look at the question, try to understand this question carefully, very carefully.
So
The
the 1 kg
fourth,
will not go down.
pardon,
So in the second case, the 1 kg will not go down.
yeah.
So because
Correct. Because the net friction force available is 16 Newton again, but the pull force is only 10 Newton. So the idea is simple. Nothing will move. So the acceleration will be zero for everything, for all. It's not for one, it's for all actually. Okay. Oh, sorry, I was mute actually. Okay, so now let's start from here. The 1 kg block is being pulled by 10 Newton force, right? So that is where the motion, like the tendency begins actually. So the 1 kg is pulled by gravity by 10 Newton of force, but it will not move as we have discussed because the net frictional force, the net frictional force is sufficient to balance the net pull force, and therefore the motion will not begin, and A will be zero for all. Now, once we know that A is going to be zero for all, we need to start with the block which creates the tendency of motion. So it's definitely the 10 Newton, the 1 kg block. So now the 1 kg is being pulled down because there is no acceleration, so the tension must be 10 Newton. So now the same tension will go to the 4 kg block somewhere here, and then it will try to pull towards the right. We know that friction can develop up to 4 Newton. So 4 is developed by the friction first. So friction will first try to oppose it. One friction will fail, then tension will develop because that is the tendency. So now friction will oppose, then because friction is not able to balance, then the remaining 6 Newton will develop from the tension. Now that 6 Newton will pull the 3 kg block, but we know that friction can go up to 6 Newton, so it will completely balance. So now there is no tension developed in the last string, and therefore there is no tendency for the 2 kg block to move, and therefore the friction is also zero. So now what you can realize that if the things are in motion, it is pretty easy to solve by the laws of motion. The real problem comes when things are not in motion and you need to analyze things organically. So you need to realize that in which direction it will have tendency to move, and then accordingly you need to proceed and solve. Okay. So I hope this is clear to all of you.
Yes, sir.
Is the example too clear? No. So now let's say in the same problem, if I make a small change, maybe on the next page. So, should remove this part. So we saw the previous problem in which things were in motion. So let's try to create a situation when things are not in motion, and then probably we can analyze. So let's say this is 8 kg. This is 10 kg. The coefficient of friction is, let's say, 0.2, 0.2. This is 0.21. Yeah. So now this is, let's say, maybe let me pick point. Now this is, let's say, this is better. Okay. I think. Okay. So find the tension in each string and find the friction force acting in each block. Do it. I hope the question is clear. Find
Yes.
tension. Okay, are you guys solving this question?
Yes, sir.
Hello, hello, one.
Sir, acceleration is
Are you guys
0.
solving?
Yes,
Yeah,
sir.
so acceleration is. So now you can realize that this
Sir,
tension is to be definitely 120. So there's no option about it. So because gravity
that
is
is
going.
120 Newton.
So the other, these two forces are very much known. So now we begin with these forces.
100 Newton.
Okay, so now the tendencies are forced to go right because the 120 is bigger value, but there are many more things that you can realize in the process. So let's come back to, let's say, okay, if I believe the tendency towards right, this force is going to be, by the way, 120 for the tension. And now we can see something. What we can see, the friction will try to, if I assume the friction is trying to oppose here, so it can apply how much friction? It can apply 10 Newton max.
Yes.
So the tension developed here must be
That
110.
will be 20.
But if this is the tension acting here, so this will also 110. And now in 110 and 100, the 110 is dominating. So the tendency of the 8 kg block is to go right. And therefore, if you look at the force friction value, this is 100, so this is 100 Newton. So 100 on the left and 110 on the right. The net is 10 on the right, and friction can go up to 60 Newton. So it will go up to 10 Newton here, and we'll stop. That's it. Now this is the this is the friction value. So the friction force actually acting on the 8 kg block is 10 Newton. So this is your answer, everyone. Is
Sir,
this what
now
you
it's
got?
confused. So,
Now it is very confusing. So friction questions are very confusing of this nature because there is no, see, you are only lucky when things are in motion, and then you can add the F equals to M. So the friction question becomes really challenging if nothing is in motion, and you need to analyze things one by one. So you need to first decide the tension, okay, because the hanging mass will have definitely tension well known in advance, and then we start with the tendency of bigger force. So the 120 is bigger than 100. So full force is dominated by the right side, and therefore the tendency of the system will be to go towards the right. So tendency is important. So how they tend to move, if possible. So although they are not in motion, but tendency we can always predict. And then comes the, you know, writing the values and solving one step at a time. Now it could be possible that in some scenario the balancing will not occur. Like if you proceed this way, you will find that okay, the answer is not matching, and it's simply not possible. Oh yeah, it's possible. In such scenario, we need to go otherwise. Like we need to reverse the trend for the last block. So there are things that you need to realize. Like it's not very easy. You have to be organically move back and forth to see which combination can give the right answer. So sometimes it becomes really trickier. Like not at all easy. I mean, it can be mind blowing things. So that requires a lot of practice. And let's say I can do easy, it means because I have done a lot of practice in past. But you guys need to go through each step, realize something, solve, come back, try from left, try from right, try from middle. Okay, you have to do many more things. Okay, so let me take some new question. Maybe
so can you give one more?
you can check. Yeah, yeah. That's why the values is very important. So I'm trying to search for a better value problem which I have given, and all this problem I have created in the class itself. So I used to create this in class. So new variety of problems.
So,
Yes.
so our acceleration will be 0.
So what is the net pull force? 20 Newton, right? So the rule is simple. First, you assume there is no friction. If there is no friction, then what is the net force? 20. Okay. So now you check for the net frictional force available, which is called the limiting friction, the upper limit. So if you add all the values of friction, upper limit is 10 plus 16, 26 Newton. And because the 26 Newton is bigger than 20 Newton, so friction is always capable of balancing the net pull force. Do you understand now?
Yes, sir.
Okay.
The net force
So
where?
let's do one. Net pull force. Net pull force you need to think of without friction.
Oh, yes.
What is the step? Step one is thinking processes, thinking algorithm, calculate net pull force without friction. Calculate net friction available. So you calculate the net pull force if Fs max summation exceeds the net pull force, then A will be zero for all. But if it is not so, it will move, and then once it will move, then you know how to solve. So that is not I'm going to discuss. So what I'm going to discuss is only things which case acceleration is zero. Okay. So maybe the last one from this category. Every problem that we are solving are unique problems, and it's not at all easy. So these comes under the category of the most challenging question of friction. Although it's very easy, but only when you have enough practice. Yes, it's nightmare. And in SCORMA, there are just very few questions which are worthy of appreciation. There are three, four problems which are really good. I mean, I hope you have solved those questions. In case you missed, I'll
Yes, sir.
maybe not. Shoot, let me put more blocks here. One. Okay. So I'm just writing the frictional value 0.1, 0.2, 0.2, 0.3, something random. And let's say the masses are 4 kg, and then this is 2 kg, 6 kg, 10 kg, just random, any value. Let me calculate something here. 30, 12, 2, 4, 6. So now we can take here maybe um, okay, now solve this question. Find everything.
So is that 13 kg on the right?
Oh yeah, 13, 1, 3, 1, 3. That's my bad. It's not 1.
Sir, I got all except that last 4 kg block, so that it will move that 4 kg block.
Okay, just a moment. Just a moment.
So 1 minute is the last.
Yeah. Okay. So let me solve this question. Now, if
So
you
1 minute, sir. So
oh,
done, sir.
oh,
So done, sir. Hello, sir.
so this is definitely 130, right?
So that is 130 newtons.
And
Then
this is,
100.
100.
these two values are, I think, pretty much obvious. So
Yes.
this is we now where to begin with, the right or the left. So we'll start with the higher value, right? So 130 means it will pull 130. Okay. Now the friction can balance up to what value? 30
30
Newton.
newtons.
So 30 to 10 to balance, and the rest 100 will come from tension, and so that's 100. And then 100 will try to pull the 6 kg block towards the right. Then friction can try to stop it by what value?
12 Newton.
12 Newton. So let's say that 12 Newton is acting this. So how much tension will develop here? 88
88
Newton.
Newton.
Now come from this side. So the last block you need to be very careful because here the 100 is already there. And you can see that by the time you're coming to the sixth block, the tension has gone down to 88. So the other tension is going to be definitely less value. So the last 4 kg block will have tendency to go left now, isn't it? So the last 4
Yes.
kg block will have tendency to go left now, that is for sure, and therefore the friction is again We need to analyze first here, not there. So now this turns out to be how much? 100 minus 4, which is 90. How much?
6.
96.
86. So now the tension, oh sorry, what I'm doing is, it's
Yeah,
4
so the
Newton
tension.
and the tension is 96. So 96 is left and 88 is right on the 2 kg block. That's a very interesting part. So the net value is 8 Newton, and we can see that friction can develop only 4 Newton. It means, oh no, it is not possible.
Sir, I got
So
values.
yeah, so I think this is the wrong analysis. Then we need to go back to the same thing. So if I continue from here, 88 Newton. So I need to in fact change the before value also, 88 one, because things are not going to balance if I continue even this way. So I need to go back
Sir,
something. Yes,
hello, sir.
yes, tell me.
Sir, that 10 kg block has a tendency towards friction like 30 Newton.
Mm,
So I took that as 10 Newton, and then, sir, it would balance, sir. If we take the 30 Newtons as 10 Newton, and then the other friction will balance. So the force
yeah,
friction will balance if we take the.
correct. So now that's why we have to analyze from the left side, and we'll check for this. So if we analyze from the left side, because the tendency is happening, and because what we can see that 100 Newton has come here only, so other will decrease. So we have to analyze from this side. So let's do it from this side. 100, it will oppose how much? 4. Tension will be how much?
96.
Now 96 will pull the 2 kg block this way. Friction will act this way. How much? 4 Newton. So how much tension will develop here? 92 Newton. Right? 96 minus 4. And now 92 Newton force will pull the 6 kg block. Now this I will remove. You need to rethink about the entire development. This will all be changed now. So now 92 will pull, and therefore the tendency is to go right, which is, tendency is to go left. So 12, 12 minus this. This is 12. This is 80 Newton. But it will still not work if it is 80 Newton. And if I add 12, it will become how much? Yeah, so I think here the change is coming. Okay. Here the 100 Newton is trying to pull right, and then this will add 12 left. Tendency will be what? If the tendency is not 100, this will also change. So even if I add this as 12, okay, now things will change.
So then also it will pull it. Yes.
Yeah, no, that's fine. This is how much? This is 104, right? So this will be 104 Newton, and 104 Newton and 130 is right. So this will become 26. Then only it will balance. So it's not really easy. It's a nice question. And there is no way to solve. I mean, you cannot do anything except you have to go back and forth to try and adjust which one is going to give you the answer.
So why can't we change the value of the pink block
Because the
friction value?
friction, we cannot exceed the friction, but we can reduce the friction. Let's say if the limiting is 100, so I can go anything below 100, but I cannot go beyond 100, isn't it?
So
So
then
that
we
is,
can't take it as 8 Newton as friction force, simply pink block.
so now here the limiting, see, the rule is simple. The 10 kg block will start moving later on. So now the 130 will pull it like this, and now some tension is already developed here. So we need to check which one is there. So the 6 into 2 is 12 Newton. The tendency is to go this way, and the 10 kg block is experiencing some tension also. So 10 kg is the deciding factor. So we can see here that 92 plus 12 is 104 Newton here, and now one side is 130 Newton. So how much friction we need here on the 10 kg block to balance it?
26 Newton.
The answer is, the idea is like the tension from the left is developing quicker than the tension from the right. And so on the 10 kg block, it is the friction which is coming later on. Okay. Now, if you are saying that if I take that, how much you said? 10,
8, sir.
8. So if you take 8, what will happen? The 8 Newton on the 6 kg block. Okay, you're saying the 130, then this will go 30. So it is acting 100. Yes, yes, that is also possible. 100, if we keep, and if we keep this as 30 only, then the friction will become 8 here. And that is possible.
So 10 is possible or not towards the 30? 10
No, this is
newtons.
this is possible. Which 10 Newton for what?
So the friction force for the 10 kg block,
Friction force for the 10
and then
kg.
you push.
Friction force for 10 kg, how much you can take? You can't take 10 Newton. That's not possible actually. Because 130 cannot be balanced by any force which is not less than, I mean, which is less than 130. So we need force 130 exactly. What we have decided
So
is that
no,
mostly
like,
never happens. Please tell me.
so in that string it would be 120 newtons. Then
Hmm.
in the second string it would be 108 newtons, and in the
So how
third
it will
string it would be 104
come on,
newtons.
come on. You have to balance every block individually. So if one block is not maintained, you cannot proceed actually. All block must be at rest, na? So net force must be zero for every block, isn't it? Understood? So what you're doing is you're not balancing one, then trying to go ahead. How it is possible?
So I'm getting a balance with equation.
I, how it is balanced? Like if you're saying 100, like tell me once again, which block you started with? Uh,
So in 10 kg block, that
hmm,
the string would be 120 newtons,
120. Okay, fine. So on the 6 kg block, what is the net force?
108.
What is the net force?
So can I send you my data?
Yes, you can say. No, what I still you can do is understand here. It's easy. What you're saying is either you're not saying properly. So on the 6 kg block, you're saying the force on the right is 100 Newton. How much? 120.
110.
20.
120.
On the left, how much is this?
108.
So how it is balanced? Come on, what you're saying?
And the
How one
friction. So friction force
108
would
is
be 12 newtons. So
okay, okay, okay. You're saying the 102 is the tension force and then 12.
yes.
Okay, okay. So let's say we can do that also. So now I think you're going right. So this is 120 and this is 108, and then you're saying it's 12 Newton. And
Yes.
if it is 108 acting here, then for this we have 108 acting towards the right. So okay, and what about the friction
Total
force?
4 newtons.
Left or right? So let's say this is 4 left. We have 104 here, right? 104.
Yes, 104.
Yeah, that is also balanced. Yeah, that's correct. Yes.
And then
So we are
100.
getting, yeah, yeah. Actually, we are getting multiple options in this case. This is a more serious question. Like things can change drastically. But what is the problem with this? On the 4 kg block, saying now the tendency, the tendency for the system, if you look from here, the 130 is left, right, and this is left. So the tendency for every block, the system is right side. The extreme block must have the tendency towards right. So at least this block will have right. So this will go towards right, and the tension will develop left. Okay, this is the right way of doing this. So 30, this is 100. 100 will go this way. So this is 8. This is 92. Okay, this is 12. So 18. So hopefully what you can get is up to here is fine. So this part is done. From the left side, 100 Newton is dominating, right is 130. So this is 100, this is 130. Now if I proceed one step ahead from the left and the right, the tension becomes 100 Newton here, plus 30 is balance, and from here 96 because 4 is balance. So the dominating on the this two block, if I look at the bottom in the middle two block, the tendency is to go left, right only. So if the tendency is to go right, so 100 will act this way, this will act then 12. This is 88, and then 88 will pull this way, and 96, 88 and 96, 8 Newton. So that's not possible. 4 Newton. Okay, so things will change here. So now we have to change here 96, 4, 92, 92, and 100. Okay, so now we proceed one step ahead. Then this is dominating. This is this is the right answer. This is the right. The 8 Newton. Because what I'm doing is we have to go proceed one by one. Let's say you start from think from here, this perspective. So 100 left and 150 right. So the tendency for the 10 kg block is to go right for sure. So even if you ignore all the other forces, and therefore what you can see that the 30 will be opposed and 100 will be left. Now on the other side, because the tendency of this 4 kg is to go. Okay, what I'm doing is to go left. This is the same thing what I will do. Yes. 100 this way. This is 100. 26. The number 6 and then 100. Okay, so see, we have actually very too many possibilities here coming. All values. So we'll start with the first possibility. Like 130 here is fixed. We cannot change that part. 100 is fixed here. We cannot change this part. So now we are left with these four blocks with 130 right and 100 left. Okay. So we have to analyze one by one. So we have to analyze this, cut this part. So if you add all friction forces here, how much is that? 12 plus 4, 16 plus 4, 20 Newton. So net friction force is 20 Newton. So here we can develop up to 120 Newton. Still it will be balanced. Because if this tension is 120 Newton, then the three block will be balanced by the friction forces. Mhm. If I take these two parts, then what is the friction forces? 4 and 4, 8. We need 108 Newton then to balance these two parts. Okay. And then if I take here, it needs 10 because this 100 is 4, 104. Even this can balance, but the problem is if that is the case, if I remove this part, it will pull this. And if you pull this with 100 minus 100, okay, if I pull this way, then all will oppose. So, the 12, 4, 16 plus 20, this 21. That's not possible. So definitely it will not be force. So this will be practical. Okay, so this has actually become really, I mean, difficult problem. So what I'll do is only I can solve the right way. Now here you need to analyze a lot actually. There are too many blocks, so there are too many analysis also. So the 130 is acting right. So if I cut from here mentally and imagine this, because I am not, let's say, if we are not able to decide that the tendency of the system is right or left. Imagine if you remove this string at all. If you remove the string, then the 10 kg block will have definitely tendency to go right. And so the tension it will try to develop is leftward. But if you cut from here and if you think of the remaining, the 100 Newton will try to develop the tendency towards left. And all friction will oppose. So it will oppose by 12 plus 4 plus 4, that is 20 Newton. So the net friction that can act is 20 Newton, and therefore the tension should develop here only 18. But this will try to develop 100 Newton. So there is a tug of war. If I cut it from here, the left is trying to develop 80 Newton, the right is trying to develop 100 Newton. So now which will dominate? So the answer is the bigger one will dominate. So now here the 100 Newton development is correct. So now we'll take this as 30 Newton as we had earlier, and the 100 Newton will come here, and so the 100 Newton. So now again we have 100 from this side and 100 from this side, and the chance is that if I cut from here, if I cut from here, and the tendency is to go down, so this will be like 100 down, and the friction force can balance up to 4 and plus 4 8. So 92 is the value from the left side, and here if we remove the 12, the 88 is the value from this side, and therefore the 92 will dominate. So now the remaining part will, this will have 92, like out of these two, the 92 will dominate. 92 will have the upper hand, so the tendency will be left, and so the 2 kg will have friction force acting around of 4 Newton. So now we can do it, like the tendency is to go left. This string will go left, friction will act this way. No, no, it is trying to go. This is 92. How much? 400, and this is 4 Newton. This was 96. And 96, this was 4 Newton again. 92, yes. 96. And now 92 is acting towards left, 100 is towards right. So what we are left with is 8 Newton. So we need 8 Newton towards left. So this is the right answer. So the distribution of force is like this. Now you can leave this question now because there are a lot of analysis involved in this. And probably you will never come across problems of this nature in which we have multiple blocks and multiple possibility of the friction forces. But it's a really nice question. So now we can go to the next concept, which we are been waiting for. But before that, there is one concept which is left. Angle of friction. So as we have discussed, I mean, already we have discussed this concept, but just as a formal definition. So let's say we have a plane, and on the top of this plane we have a block. N. So this is block. A really bad diagram. Nevertheless. So now if we do the FBT like the usual, you can do the normal like this. Now depending on the tendency of the block, let's say that depends on how I apply the force externally. The block can go anywhere. So now let's say if the block is trying to go towards left, how the friction will act? Towards right. So if you try to push it this way, the friction will act this way. So depending on how you create the tendency of motion, the block will have different, direction of friction acting on it. So I'll just choose one of them. Let's call it Fs. So now we can understand that these two forces are developed between the block and the surface of the contact, or you can say ground. And as we have discussed in the last class also, this is called the surface. These are the components of surface contact force. So if we wish to replace these two by a single force, what that value will be? So here comes the answer. So this is what we call the surface contact force, the resultant of surface contact force, and this is what we have been using even since the last lecture. And this will be denoted by R. Now, because the Fs can have any direction, so this R can be anywhere on this circle, like it's like a conical shape. So as you rotate the Fs in the bottom at the bottom, so if the Fs will change the orientation, and if Fs will change the orientation, so the R will also change, but it will remain something like this. So this angle we call the angle of friction or lambda, or this is also called cone of friction. This is called cone of, and it is very easy to calculate the tan lambda. So we can add tan lambda equals to Fs by n. And since we know that since Fs is always less than or equals to Fs max, we call the limiting value, we can say n tan lambda is always less than or equals to mu s into n, and because n will cancel out, so tan lambda is always, so equality will hold true when it is limiting friction, and this is what I use in the derivation of the formula for the F minimum required to move the block. For limiting friction, the tan of angle of friction is equal to the mu s. Now, why it is important? Because in the examination, it is possible that in future JEE may ask this question that instead of giving you the mu s, they may give you lambda. So if the lambda is given for the limiting case, then that is the tan of that lambda is always equal to the coefficient of the static friction. Okay, and this is what I used even in the derivation of those things, if you remember. So the idea is, if we have a block kept on the ground, so there are two ways of thinking. The thinking is, if someone is applying a force like this, even like this, the tendency is to go right, and therefore the R force will always develop like this. R is bound to develop like this. And now this angle we will lambda. That's it. And the gravity will act like this. Downward. Now, if they ask you if f is maximum value, if f is maximum or minimum, like f is such that the friction is limiting. If I'm saying that you are applying force F and the friction is limiting value, so block is about to move. If the motion is impending due to force F, if I'm saying that force is good enough to just move the block, which means this implies the lambda is tan inverse mu. So like we have reached this condition. Okay, so lambda is tan inverse mu. So in such case, we can say that F will be equals to R sine lambda and mg is equals to R cos lambda. And therefore, you can just equate these two values. So if I divide these two equation, what will you get? F by mg is how much? Tan lambda. And you can see that the tan lambda is mu s. So this is exactly equals to mu s mg. I mean, that's a direct answer. I'm doing it on a lengthy way. So we would know that to move the block, you must apply the force equals to mu s mg if it is horizontal force. So now the question comes that if the force is not horizontal,
Around the last page.
just
Done, sir.
okay. So now you realize that angle, the lambda thing that we have been using again and again, even in the last lecture, I have used a lot. Okay. So now the idea is what happens if we have a object, and now we know that gravity is acting down and the reaction forces. So let's say the applied force is somewhere here like this. Now this angle is still unknown. I don't know what is this angle. This I need to figure it out. And this is mg. And the reaction force will be definitely because the tendency is to go right. So reaction force must be somewhere here. Just do it right now. And as we discussed, this angle with what we call, if this is the reaction force, see what I'm doing is if I'm showing you the reaction force, then I do not represent the normal and the friction. That's the idea. So the normal and friction should not be drawn actually. That's fairly simple. Okay, so now the R is something like this. This is let's say lambda, and if it is really limiting case, because if the block is about to move for limiting case, so we know that tan lambda must be equals to mu s. So that's like one information. You can just keep it with yourself. And now because the system is at equilibrium, so we can always write something called Lamy's theorem or something, whatever you want to call it. So this angle is phi minus lambda. This is 90 plus theta, and this angle is 90 minus theta. And because by the equilibrium formula of Lamy's theorem, if you remember, you can write as R upon sine of 90 plus theta is equals to F upon sine of phi minus lambda equals to mg upon sine of 90 minus theta plus lambda. So this is the formula. This is the formula. So this is R. So what are we getting? F is how much? mg sin 181 theta is sin theta. So this is mg sin lambda uh, upon, and then this is sin uh, 90 minus theta minus lambda, which is okay. You can add 90 minus that is. F turns out to be mg sin lambda upon cos theta minus lambda. Okay. So now the question is for f to be minimum, the because lambda is fixed, we know like lambda is constant, so theta is a variable. So for f to be minimum, we need to make this maximum. And what is the maximum of cos lambda? Cos theta, cos of angle 1. So we know that the f minimum will be mg sin lambda is the answer. And also we know that for cos theta minus lambda equals to 1, the theta minus lambda equals to 0 because cos 0 is 1, which means theta and lambda must be equal. So if you exactly apply the force at lambda angle, then you will get the lowest value of force which you can solve. And if theta, if this is lambda, so you can understand this is 90 minus lambda, and therefore this is the right angle. So it means the R and F must be at right angle for the minimum value. That is idea. So the F must be right angle to the R, and once it is right angle to the R, it's the lowest value. So we can analyze the same problem in variety of ways. And now we know that because tan lambda is mu s, so what is sin lambda? So sin lambda is definitely mu s upon
ux
1 plus
upon
mu
1
s.
plus mu s square.
And I can just substitute here and my job is done. So this is the same answer, the minimum force question. So for minimum force, the condition that we have derived is that the applied force should be perpendicular to the r vector. Okay, so that is how you can prove it many ways. And one way was like the way we solve it. So we have solved in three possible ways. Now the vector notion. So the what is vector notion? I mean, so first of all, the r value will have fixed orientation. Lambda is fixed, and the limiting case this is always fixed. This you cannot change at all. So it is a fixed value. Okay. Now f is something that we have to decide how it should act. So the idea was like from the concept of gravity. So let's say gravity is a vector which is already there. So mg is this is the mg vector. And now r vector we have to draw from the, let's say from the tip of the mg, I draw the next vector r vector. So let's say the r vector is something here. Something we can draw. So r maybe the mg that's possible. Yeah. So this is the mg vector. This is the r vector. Maybe I can go the other way also. And now the question is how the f vector should be. So the f is the resultant of these two, so f must be like this. So the f vector turns out to be something like this. Because this angle is fixed. Now the question is how to minimize the f vector. So I think the minimum value of f is only possible when the f is something like this. Because the shortest distance from the point, the tail of the first vector to the tip is only this much. It means if the r is exactly till here, then this is the minimum value. So that's why in order to minimize the force, we must do this triangle. And in this triangle, this is right angle. And because this is mg, you can directly say that f must be equals to mg sin lambda. Okay. So we are just doing the triangle, and in order to minimize it, we are just making it sure that the f is always perpendicular to the r. Okay. And because the tan lambda is mu s, since tan lambda is mu s, so therefore f is mg mu s by. Okay. So I hope the thing which you did not understand that day, I mean, it should be making some sense to you now. So now are you able to understand this?
Yes, sir.
So you just need to modify your diagram, and once you draw this, it's easy. Okay, so now I need to change the direction. This down. Oh, sorry. One is mountain. So this is down. This is right. So force is actually like this. Yeah, yeah, because it is in equilibrium. Okay, my mistake. So in the beginning also this was actually like this. So if the R is this way, to balance it, the force must be coming back to the same point because it is in equilibrium. So the three forces must be cyclic. And now to minimize the F, the only way was to bring this till here and convert it into this right angle triangle. All right. So let's do the next concept. And you also must, I mean, practice the last lecture. I mean, that is also very important question. Those are the challenging problem. You need to think a lot about reaction force and all. Oh. So now we'll start something called two block problem. So let's do some practice, a small practice. So we have one block, two block, three block, and four block. There are many blocks. So in multiple block problem, the problem is that how to understand the frictional direction. So let's do some practice of friction forces. So to understand the direction of friction, the rule is very simple. Okay, so I'll come to that rule, but before that, let's do even something easier. So imagine if these are the situation in which all surfaces are rough and the blocks are trying to move in at different velocities. So this is trying to move 2 meter per second, but this is trying to move at 3 meter per second. But this is again trying to move 1 meter per second, but this is trying to move 4 meter per second. So now let's say I have to draw the friction forces for each block. So we'll do a simple practice here. So draw the friction force for each block. Now the friction is developed by the surface, and surface must decide how to apply it. So when it comes to the friction force on the one block, the block number one, it is the surface of two that will decide, not the one. And for that to decide, the two will see how one is moving. So now two becomes the frame of observation, and two will try to observe one, how one is moving. So as you can see, the values are given 3 meter per second and 2 meter per second. So the 2 itself is going towards right with 3 meter per second, whereas 1 is going with 2 meter per second. So in the frame of 2, how 1 is behaving? That's the question. So is it going right or is it going left? Tell me. So if I talk about 1, the first block, what is the tendency of the first to go towards the right or towards left with respect to the surface to
Left.
left? Now the tendency is known to us, so we can say with clarity that the value of friction will act right for sure. And let's name it by F1. Of course, it is going to be kinetic friction in this case. So 1 is done. So we'll come back to the second block. Now the action reaction pair must be shown directly. So F1 is acting on the right, so the same F1 will act left on the other block for sure. So there is no need to think much. So now there is a problem like 2 and 3. Here we have one more friction. So to apply the friction force on 2, who will decide?
3.
Okay. So now the 3 will decide. Now tell me how 3 is feeling, how 2 is trying to go, right or left? In the frame of 3, how 2 is trying to move towards right or towards left? Tell me.
Towards right.
So now the friction is decided. It will act towards left. So let's call this F2. So now comes the third part, number 3. So now without thinking much, apply the F2 as the action reaction pair is always there. So now beneath the 3, the 4 will decide how friction will act. So according to 4, how 3 is moving, right or left?
Left.
Left.
So now the friction will act towards the right. So now the friction will act towards the right, and that we will call F3. And now comes the last block, the fourth block. So without much thinking, apply the F3 as the action reaction pair. It is F3. And the ground is the one who will decide about the friction. So what do you think? With respect to ground, where the block is 4 moving, right or left?
Right.
So the friction is going to be left. So now this terminates the analysis of friction forces. So this is how we think. So there is a rule for deciding the direction of friction. To understand the friction direction, you need to think of tendency. And to understand the tendency, you need to think of what if there is no friction. So the thumb rule of deciding the friction is called assume there is no friction, check the tendency, and then apply friction to oppose the tendency. That's simple. The thumb rule for direction of friction. Step 1, assume there is no friction. Step 2, check tendency of a relative motion of point of contact, not bodies. So we always check the relative motion of the point of contact, not the body as a whole. Let's say when I say that when you walk, so you always think that your body, no, your foot will decide, not your body. So when you try to walk, you try to press the ground backward. So you, if there is, or if let's say if there is no friction, your foot will slip backward if you try to move the way you move, and therefore the friction will act forward. So we don't see the motion of the object, we see the motion of the point of contact, how the point is trying to move. So when you try to walk, you press the ground backward. So if there is no friction, your foot will go backward, and so the friction will act forward. Okay. So assume there is no friction. Step 2 is check tendency of relative motion of point of contact. So friction always opposes the relative tendency of motion of point of contact. The role of friction is to oppose the tendency. So if there is actual motion, you can always apply. But even if you know the tendency, you can apply the friction. So before we again solve question, let's do some practice.
Sir, I want to put that last one, that step 3.
Done.
Done, sir.
Mm. So now comes the something, some more practice. So let's say if I apply a force on the upper block, friction is present everywhere. And now I want to analyze the or draw the ABD. So now the first thing you need to understand is it is the applied force that will try to create the tendency of motion. Now you are applying force on the block M1. So what will be the tendency of M1 to go right or left or what?
To go right.
And that is obvious thing, like I mean common sense. So we know that M1 will tend to go right. That's tendency. And because the tendency of M1 is to go right, then M2 will, the M2 means the surface of M2 in contact with M1, that will try to oppose it. So the obvious direction of friction is what? Left.
Left side.
Let's go left. Now for M2 it is easy. The action reaction pair will be always there, so that's not a big deal. So we know this is going to be F1. So we started with F because that is the driving force creating the tendency in system. Then I got F1. And now that F1 got transferred to M2. And now this F1 will try to give the tendency to M2. So now how M2 will tend to move? Right. So what ground will do now? So ground will definitely apply friction force left. So there is something called the source, the driving force. So M2 would not have moved if there is no F1. So let's say if the friction between M1 and M2, if I make it 0, although ground is rough, but I make the friction between M1 and M2 0, coefficient 0, so there is no friction. So even though the tendency is there, but friction will never develop. And because friction will never develop, M2 will have never the driving force. It will always lack the driving force, and so it will remain there only forever. Understood? Yes or no? Now, if I say ground is frictionless, then and the F1 is there, so M2 will only move forward, only move right side. There is no doubt about it, isn't it? Are you getting my point? What I'm saying? If I'm saying ground is frictionless, then the only tendency of M2 will be to go right or left. Where?
Right.
Right. Now again, because there are two objects you can see going right. The let's say F2 is absent for the time, and we have M1, we have M2, and because the driving force is capital F, and F1 is the force developed, so there are only two possibilities. There are only two possibilities. That either F1 is equals to F or F is more than F1. F cannot be less than F1. Why? Because every force developed cannot exceed the driving force. That's simple rule. So F is the driving force, and every other force is the consequence of that. So what comes as a consequence cannot exceed the cause. So M1 will have only possibility of motion is towards the right, because the net force possible is towards the right. Or in worst case, it will not move at all. Now this is something you need to realize. So either M1 will not move because F1 is exactly equals to F, or if it will move towards the right. But F1 cannot exceed F to let it move left. No. So the driving force is a concept. And as a result of driving force, other force comes into picture. So they are consequence of force called F. So let's change the scenario. Again, we have two blocks. Again, we have a ground. And I have changed the condition. Now force is applied here. Now which block will try to move first? Is it M2 or M1?
M1.
Which block will move first?
Sir, M2.
So if there is no friction, that's how we start with. If there is no friction, the motion of M2 is only possible here because F is the driving force. And because M2 can only move first, so M2 will decide all other direction of friction. So we have to begin with M2 now, not M1. So we cannot start with M1 first. So we'll start with the ABD of M2. Now these are some of the prerequisite of thinking. If you are not thinking in this way, then you will always get confused. So you may get the right answer, you may not get the right answer. It depends on your luck. So now if F is moving towards the right, how the ground will react to the motion, because M2 is trying to go right, so how ground will apply the force?
Left.
The friction of ground is obvious, it is going to be left. I'll start with here, let I'll call F, and I needed to draw the friction force on the ground because that's of no use. Now, even if you look at the upper surface is also trying to go right only. So the M1 is static there, so it will also oppose the upper surface. So even here, the friction force will be left, but it's a new surface. Let's call it F. Now, this is my ABD for the M2 block, and you can see that things have changed drastically. So now come to the M1 block. So for M1 block, the action reaction pair will be always there. So F2 will act forward. And now you can clearly see that the only way M1 can move, and in fact, if it can move, is towards right. And that is only possible when F2 is there. If F2 is not there, M1 cannot move. So now the question is when F2 will come into picture? And the answer is only when F is more than F1, but not more than F1 and F2 together at least. So if F crosses the F1 value, then F2 will develop. What if F is less than F1? Then F1 itself will balance the block completely, and M2 will have never tendency to go right, isn't it? So imagine
Yes.
F1 is sufficient to balance F. Why F2 will develop? Because F2 will develop only when there is a tendency. The moment you pull F, the lower block, if ground is capable of stopping it, it will never develop the F2. So let's say ground is not capable of stopping the M2. The F1 is not sufficient compared to F. Then M2 will tend to go even further right. And then M1 will oppose it and friction will develop. So for F2 to develop, it is necessary that M2 must move. And for M2 to move, it is necessary that the applied force is not balanced by F1. So the rule is simple. If the ground is capable, because ground is a fixed body, it's a rigid surface. So if ground is capable of stopping the M2, then F2 will never develop. If the lower block is at rest, the upper block cannot develop friction forces because that's depending on the upper block. Now these realizations are important before you solve question of 2 block or 3 block problem. So let's take some other cases. So now we have 2 blocks. Mass M1, mass M2. Let's say I'm saying that the friction here is 0, but there is friction here. This is how we represent. And I have changed one very special condition. So I have applied forces both on the top block, on the. So now the question is how we can decide the friction direction on each block. So now it turns out to be like you may not be able to guess all the time, but a right guess will make the things easier. but we have certain way to guess it here. So what we can do to understand the direction of friction here? Ground is not possessing, giving you any frictional force. So whatever force you apply on M2, it is bound to move. So only fixed surface will decide whether something will move or not. But if the fixed surface is not giving you any constraint, then the object is bound to move. So here both blocks will move for sure. So now the question is how friction will develop between them. Will it be right or left? How we decide? So the answer is pretty simple. To decide the direction of friction, what is the step one? The step one is assume there is no friction. Okay. So now if you assume there is no friction between the block also, what will be the acceleration of each block independently? That we can calculate. And the acceleration of the two will be, because there is no friction, so they can move independently with these accelerations. So now we can take the same cases like case one. If A1 is more than A2. Now if A1 is more than A2, so the M1 will try to go ahead of M2. So M1 will experience the friction force in which direction? So what will be the direction of friction force? Tell me guys, what happened?
The left side.
Correct. So the M1 will experience the friction force on the left. And as the action reaction pair, the same friction will act on M2 towards the right. Apart from the, so given a situation, you can always decide the friction force. Okay. Okay, have I shared the like frictional sheet, the resonance sheet which I normally share? If not, then I'll share today.
So one question.
Yes.
So in the acceleration of 2, it should be F2 by m1 plus m2.
Pardon?
So acceleration to F2 by m1 plus m2 would
No, this is the acceleration when we assume there is no friction. Assuming, because to find the tendency, this is how we think. This is thinking process. This is not the value. This is not the answer. So assuming there is no friction between blocks. So this would have been acceleration. And now from here you can guess. So you have to draw ABD as per some situation. So you will assume, okay, this is more than, or if you know the values are given numerically, you can calculate and you can understand what is the answer. So now the question is, what if I assume incorrectly? So the answer is nothing will happen. You will still get the answer with opposite sign or negative sign will come into picture. So when you solve a question in which you assume friction randomly without thinking much, then the answer of friction, if coming out to be negative, it means it is the wrong direction in which you have assumed the friction. It should have been opposite. But in the situation of static friction, one need to understand the direction first before applying. So of course that's why the thinking is a lot. I mean, you need to think a lot about every question. So what you can do is you can just check all such problem and try to first draw the ABD. Because once you do draw the ABD, you're almost done. The rest is just for the namesake. The rest is nothing much. In a problem of 2 block or 3 block or maybe 4 block or 10 block, what matter is the FBD, and for that you need to understand the concept of tendency of motion. And for tendency, you need to think of the driving force for each object. Sometimes the driving force is the applied, sometimes it is the developed, because I am applying force on one object and others are, waiting for me for their behavior to happen. So let's say if I have 3 blocks,
Sir, in case 2, if A2 is greater than A1, so the
it will
upper
change.
block will,
Yeah. So then upper block will have frictional force forward and lower block will have frictional force backward.
yes,
Yeah. So now imagine if we have 3 blocks, like you must have seen this in SC Verma, and the force acting is on the middle block. This is the one case, and ground is, let's say, frictionless. Rest everywhere we have friction. So now you need to understand certain things, like what is the driving force here? Which block will create the tendency? Is it M1, M2, M3? Which one? Tell me. So which one will create the tendency? M1, M2, M3, which block?
M2.
Correct. So M2 is the driver. Okay, it will decide everything else in this question. If we have more than one force, then this is the condition. This is the way to deal with. Now, if there is no friction, M2 will definitely go right, and therefore the friction on the M2 from the top as well as from the bottom will be left. And once you decide the F1, F2 value, then you can easily draw the FBD for the other. And now this is done actually. This is a very easy problem. You can see that how friction forces are drawn actually. First of all, you need to draw something like this. And once you draw this, then the analysis will do.
Sir, what if the surface is half smooth and half rough?
Pardon?
So what if the surface is half smooth and half rough, and we are applying a force on that object?
What if the
Surface on which we are, so the
like
surface is
the
half
M3
rough.
is rough,
Yes, sir.
is rough, right? Is rough.
So
Okay.
no,
So
half rough.
is
So
once
half
again,
rough and the other remaining part is smooth.
say once again, like say it clearly. Like what do you want to say?
So some part is rough and some part is smooth.
Yeah. So that's fine. If some part is not smooth, then there is no friction. That's it. But the way to analyze will remain same. So let's say if M1 and M2 having frictionless surface, so this will go. This will not come. Or let's say if the F2, I mean M2, M3 are, I mean, having frictionless surface. This M3 is bigger actually. I have done this number. Anyway, that doesn't matter. So you understood the meaning of tendency? Like tendency means if you imagine there is no friction, it does not mean there is no friction. It means this is the way of thinking. So if there is no friction, then how they would have behaved, how they would have moved. And once you decide their motion, then only you can go back. Okay. So I think this will require one more lecture to complete the two block problem. So by the next lecture, hopefully we'll complete the friction chapter and we'll enter to the
Sir, one question.
yes.
So why, so when we put lubricants on surface, so why does it make the surface more? So
Lubricant will ease out the motion of the two surface because the lubricant having this molecules which can slide. Let's say graphite, if you know the graphite having the hexagonal structure. So graphite is like a some kind of flakes. So lubricant always creates one extra layer between the two solid surfaces. So we have one surface here, another surface. Now, however thin the lubricant layer may be, I mean, for you it may be nothing. You may not be able to think about how thin the lubricant is. This even go to micrometer thickness. But they never touch again. So the thing is, the first surface can move easily over the second because these are movable objects. So you can move over the lubricant actually. So the first block will move easily and it will prevent the interlocking. So the lubricant having the role of preventing the interlocking. And you really cannot squeeze out everything. That's fundamental rule. So even though you may think they're touching, they're not touching because there's a micrometer separation. You can't see that. Okay. So that is how the lubricant prevents the interlocking and hence reduces the friction force. Also, you can think that the nanometer curvature is which is like having some yeah, so this is filled with the lubricant. So now we will never go this way. I mean, it is something like it prevents. Yes, tell me.
Sir, in the case like if two blocks are there and we pour water in between them,
Mhm.
and then if we slide them, it is easy. But while taking it uh, vertically upwards, while pulling it vertically upwards, the upper block, it is
Mhm.
much harder than sliding.
Yeah. Why? Because of the property called surface tension. So it is the surface tension and its curvature of the liquid which creates the pressure difference and the atmosphere will press it stronger than before. That you will learn in the chapter of surface tension distinctly. There is a formula for it. You can derive it also. So sliding has to do with the rolling of molecules and the pulling decides upon the pressure difference. So there's different logic in these two questions. Okay, next. So all right, so we'll discuss the rest in the next lecture. And today I'll share all the slides and PPTs and
Yes.
everything. Okay,
bye.
bye.
Thank you,
Sir.
sir.